Welcome to Data Innovation Summit 2018. It's the last panel of the day. I hope you guys have been having fun. We have two outstanding panelists here to talk about IoT. Jon Lindén from Ekkono and Charlie Lagervik from Microsoft. Welcome.
Thank you.
So, tell me a little bit about what you do at Microsoft and Ekkono and how it relates to IoT.
At Ekkono, it's all about IoT. We do machine learning for IoT. In short, we say we make connected things smart. And this has a background from the University of Borås, where a guy named Richard Koenig led the research on predictive modeling. And the outcome was a very lightweight software solution which enables us to actually run advanced machine learning out on the connected devices. So we can see everything, all the sensor data in real time, take instant actions, be independent or less dependent on connectivity, and actually do personalized training on each and every individual separate device. So that's what we do. It's an embedded software product.
Right. What industries do you see being the leaders in IoT right now, in deployments, into production?
I would say that it's certainly on the industrial IoT side, and the main reason is money. If you take the automotive industry, a car, it's unfortunate if your car stops and you have to pick it up the next day. But if your truck or your forest harvester actually stops, you start losing money instantly. So it's very much on the industrial side due to money. I very often get the question if IoT is just a buzz. In my opinion, it's not. I would certainly say that this is the fourth screen, but without the screen. That we had the TV, the computer, the smartphone, and now we have everything else that's being connected. And my main takeaway from the Consumer Electronics Show, CES in Vegas, in January was that no one talked about IoT. And I think the main reason is that it's a given. If it's not exactly. If it's not connected, it doesn't exist.
Ubiquitous.
It's kind of like something shouting in the forest. Right. No one is listening unless it's connected.
Right.
So it's a given. And I think that we're going to see a very rapid ramp up, but you have to find the business cases, and that's more in the industrial side right now.
All right, well, let's talk about what's driving IoT. Is it operational efficiency, or is it new revenue streams?
And my experience when it comes to especially on the B2B side, everyone is very interested in and excited about new business opportunities, new revenue opportunities, but at the end of the day, you buy on threats and issues. How do you solve specific issues? That's what actually generates the budgets, that's where you can get money to spend, and that's typically where it starts. How can we solve a very urgent issue? And something like predictive maintenance is a no-brainer. I mean, you don't want the first call from your customer to be that your machine is broken.
Right.
You want to actually reach out to the customer saying that your machine actually needs some maintenance, and we're going to help you, and we know what you're going to do, and so forth. So it's definitely a very good case for how it's being used, connectivity in combination with smartness.
Let's talk just for a minute about what IoT actually is.
It's a very broad definition. It basically lacks a definition. That's fine. Yeah. It's not an industry. It's not a vertical. It's a word that kind of aggregates a lot of things into it. Internet of Things, and that's good. Like I said before, we've taken the step from hooking up people with smartphones to actually hooking up everything else. And this is also where the combination of AI, machine learning, and IoT comes into play. Because with a smartphone, we always have a smart interface, which is the human who's operating it. You have the GUI and you have a smart human operating it. With Internet of Things, they have to become autonomously smart. Otherwise, with billions of connected devices, we're going to spend too much resources on manually supervising and managing all these connected things.
Right.
So everyone's going to work basically in control rooms. That should be the future work for anyone who's a teenager these days, unless we automate it. So we make things slightly more smart, which is a necessity, which is why these two are so closely related.
Right.
Trying to get a good context of what is actually the surroundings where the devices operate to make clever decisions on the edge. And I think one of the big trends we see now is that you want to combine the power of the cloud where you have all your data and where you have really advanced capabilities of building algorithms, and then bringing that capability down to the edge or closer to the context where the machines and device exist, and make local decisions where you don't need to loop to the cloud or loop back to the servers to make decisions. And I think we will probably just see...
Is that where things will be moving?
I think it will just accelerate. I think you will see more of that because the power that you get, I mean how quickly CPUs and even low power CPUs, how much more computer power you will get on those devices will just, so to say, increase the capabilities that you have on the edge. So the reason for sending things back to the cloud or back to the backend servers will become less and less, and you will use that to have an aggregated view or have a control and have a digital twin that you could then control the devices on the edge. But to actually run the algorithm, even though they are pretty significant, you will probably in the near future don't have that much hardware limitations even on the edge.
It's going to be a necessity that in order to manage this exponential growth in data, you have to take a layered approach. It's not going to be an either or.
Right.
And some things are better done at the edge, some things are better done in the cloud. Like, instead of aggregating 2.5 terabytes of data from an airplane per day, where most of that data is very relevant right now in real time, but the best before date actually exceeds pretty quickly, and where you can actually learn in the meantime and constantly, it's kind of like a Tamagotchi. The more you feed it, the better it gets. Same thing with a machine learning model. The more you feed it, the better it gets. That actually aggregate the knowledge in that model instead, so you can execute that continuously. That's a better way of processing that real-time data, and you're going to send curated and better data to the cloud, which is better suited for doing cross-referencing. Cross-referencing between your entire install base, like all your trucks, instead of that specific truck. That specific truck is better managed out on the truck, but all your trucks, the fleet, is better managed in the cloud. And also for manual supervision, the cloud is much better. For automation, the device is much better. So it's not, definitely not going to be a versus. It's not going to be an either or. It's going to be a combined. It's going to be a layered approach. It's the only way we can do this.
I definitely agree on that, and I think also where we see limitations now from an IoT standpoint, it's most often not the CPU on the edge, or it's not even the capabilities on the cloud or backend side. It's really networking. So sending data, and particularly if you want to send huge volumes of data, networking is even today becoming the bottleneck. And I don't think 5G or any technology will solve that, because the volumes of data will increase quicker than the networks will evolve.
Absolutely.
So the only way I see this happening in the future is that you need to be able to provide algorithm closer to the data, because you will not be able to move all the data up to the cloud. But you will definitely need to combine these. So you need to train the algorithm, you need to use the cloud or the backend servers for what they are good at, but you also need to be able to actually execute things and react to things quicker on the edge and on the devices. So definitely a combination.
IoT that's coming. Is AI an important part of that?
It's crucial. I mean, it comes back to, if you want to do things more instantly. If you just rely on uploading the data and then processing and making decisions and sending back, let's take a truck. They typically upload the data once a day. When we talk latency in the telecom space, it's normally a round trip time. Now we're talking a day. You're looking at a day old data. It's very hard to be predictive when you're looking at old data. That's kind of the latency in that context. So there are a few things, some actions, some activities that will require instant decisions. And then you want to automate those decisions, and AI, machine learning, is built for that purpose. So it is very, very intertwined. They're very related due to all these different things. It makes a lot of sense to combine AI with IoT, because they are so related. But you're going to see that they actually push the boundary, because they see the value that it's worth to add this cost on the hardware for the premium products, because you're adding premium functionality.
Well, if it becomes an essential part of the product itself, it makes economic sense to move and get economies of scale.
Yes.
But I think that's part of the problem, but I think it's also that traditionally you look at the business case just for the product itself, but the big transformations in most industries is that the services business or the aftermarket business is getting increasingly interesting for the product developers and resellers of products. And meaning that if you have too low specifications on the hardware, you limit yourself on the possibilities on the services and aftermarket business. And I think that is also where we see a change now, that you are prepared to take a risk on increasing the cost for the hardware, because you know that will help you on those aftermarket and services sales as well, to have a higher level of digital and software-based services generated from the devices.
So you had a very nice example that you talked about before.
Like the Automower.
Yes.
And the thing, I mean, I love the Automower in the context of a consumer case, that I don't want an Automower to learn a garden. or know a garden. I want it to know my garden. It should know where and when it should operate. I don't understand why I have to program it. It doesn't make any sense at all. It should actually know when it should operate at a maximum and thereby reduce the consumption. So it's going to learn a lot of things, and it's going to pick up things as it's walking around my garden for thousands and thousands of hours. And on top of that, we're going to add functionality. For example, if I switch on like a vacation mode, where I tell it not to go into places where it typically gets stuck, because I don't want it to get stuck, then that is almost the same thing as posting on Facebook that I'm on vacation.
Yeah.
You don't want to do that, because someone might actually pick up you're on vacation, and that might be a burglar. So you're absolutely right. There are cases and contexts where you have to think about the privacy question. And I think this is another reason why, when looking at edge and cloud, that some things actually should stay on the device, which is my device, and I don't care if it stores it on my device if it's not accessible to someone else. That also applies actually on the B2B side, because we have machine manufacturers and they have their customer, and their customer might be a public company,
right.
And they don't want the manufacturer to know when they have production faults or the production rates. So all the data needs to be processed on premises and just send the conclusions to the manufacturer so they can support the machine. So privacy and information leakage and all these things come into play very much when it comes to IoT and connected things.
5G is hip. 5G is big. Is it coming soon, and is it going to affect IoT, or is it like any other connectivity before it?
It has to, but it's a technology, and that's the thing.
Is it revolutionary?
Like all of us, well, it is. Every generational shift is pretty revolutionary, because they're not like slowly. They're jumping incrementally, and then all of a sudden that changes the circumstances, the conditions, enabling us all of a sudden to do full HD, when it used to be that you were doing pretty poor SD in the past on TV, and then being able to do 4K. That it actually enables you to do pretty radically new things. It's going to be the same thing with IoT, that we're going to see all of a sudden that some of these use cases that are very data intense will be enabled by connectivity. This is a very important thing when it comes to IoT, and especially in combination with machine learning and AI. Do small wins. Don't try and boil the ocean. That a lot of these things that we talk about are grand, tremendous things that you would love to do. But at the end of the day, start small. If you can actually solve a small, like we have Alfa Laval as a customer, we look at 4 or 5 sensors, figuring out when you have to do maintenance, and they have maintenance cycles of anywhere between 6 weeks and 5 years. So of course, if you can learn individually for each and every heat exchanger when you should do it, based on different conclusions, that's extremely high value, and it's pretty basic as a use case, but it's very valuable. Small wins, and then use technology that is flexible, and that's what we're seeing. I mean, on the IoT platform side, we're basically seeing Azure and your other competitor from Seattle. That's what we're seeing these days. That because it's programmable, because you don't know if you actually buy functionality. When you finalize that project, in many cases you realize that was not the functionality we were looking for. So you're looking for a very programmable environment, and that's also what we bring in. We bring in a programmable edge computing solution that you can configure, add more, and kind of develop based on a roadmap. You want to configure it because you're going to find out things in the project in those 2 to 3 months of what you really want to do, and then you want to be able to shift slightly direction to get to where you want to go.
Well, that was all the time we had for today.
Okay.
And that was the last panel for the day. Hope you guys enjoyed yourselves. Hope you'll be back next year for Data Innovation Summit 2019. Thank you, and I'm signing out.